All right, so now we're gonna move on from like basic R data models and whatnot, and just basic syntax, and get into looking at functions and using like loops and whatnot. So kind of moving on to some of the kind of intermediate level of coding within R. Luckily, if you're used to other languages like Python, these topics and concepts are all pretty much the same. It's just that they're implemented a little bit differently. So how you set up a for loop, for example, in Python and R, the syntax will look a little bit different, but the idea is basically the same in that you're iterating over something, right? Okay, so we're going to start off this conversation with a discussion of functions. So if you want to make a function, you do that using the function, right? It's a really redundant sentence, right? So this function basically is what initiates a function, right? So the variable in this case is not going to be data, or it's actually going to hold the function, right? So I'm basically creating a function here called scale2, and what goes into the parentheses here is the arguments, right? So this is going to accept two arguments, or parameters. I always get those terms backwards. And then what it actually does is defined but inside the curly brackets. So basically it's going to calculate the maximum value from the data, then the minimum value from the data. It's going to subtract the minimum from each data point. It's going to get the difference between the min and max, so basically the range, and it's going to take each data point and divide each of these n values, so the data minus the min, and divide by the range. And then what that actually is going to do is it's going to rescale the data from 0 to 1. And then you can multiply the result by a scaling factor to get it onto another scale, like from 0 to 10 or 0 to 100 or 0 to 255, like for like an 8-bit or something. So this is just a simple function that accepts like a vector of data, and it just rescales it based on a custom scale, right? So whenever you make a function, you first have to define it, right? And then afterwards, you can actually use it. So let me hit run here. Maybe. Oh, you know what? It's because this is sitting here. Sorry, let me change this. Oops. Let me restart R. What happened there was I had quit R, but I never actually reopened it when I started my last session. So anyway, we'll just jump back into it here. Okay, so we're back into R now. Just gonna clear the console out here. All right, cool. So if I hit run here, that initiated this object. So now you can see over here, there is this function now exists in your set of variables under your environments. So it's under the functions heading here. All right, so we haven't actually used it, but it exists. Now, if you call in the object, let's just put in scale2 and see what happens. So if you just type in the name, it basically just returns the function definition. So if you want to see it, you can see it that way. Alright, so now we're actually going to use the function. So here I'm just creating a set of values, and then I'm running the function on it. So the data object is the vector of values, and then it's going to the scale is set to 100. So basically what that means is it's going to rescale all the data from 0 to 1, and then take the results and multiply it by 100, so it rescales it actually from 0 to 100. And then I'm just doing the same thing here, but I'm rescaling it by 1. So effectively it's just maintaining the 0 to 1 range. So there we go. So there's the original values. There are the values rescaled from 0 to 100, and then rescaled from 0 to 1. Okay, so anyway, that's the function. It's pretty simple. So again, you use the function. You can define some arguments, give it a name, and then what goes in the curly brackets here is it defines what the function does. One key thing just to note is you have to use the parameters or arguments you define here. You need to use those same names inside the function. Another thing is worth noting, and this is the same with other programming languages. By default, I guess for Python specifically, and most other languages, the the default is that any variable that's defined inside of a function is local scope as opposed to global scope. So for example, n or d is really only going to be available in the function. You can't use it outside the function. So again, as a side note here, if I just called n, it's going to say object n not found because it doesn't have global scope. It only really exists inside of the function. Okay, cool. That was us using the function. So here's another example. This is a function that calculates root mean square error, which we really don't need to get into what that is because this is just an example. But basically the idea is it's a measure of like accuracy for like doing regression, and also for like positional measurements. So if you're like a GIS person, for doing like georeferencing, or the accuracy of a coordinate, or the accuracy of like an elevation measurement. So here's basically what the function does. So again, this is the name. Here are the values that it's going to require. So this is the correct x coordinates, the correct y coordinates, the predicted x coordinates, and the predicted y coordinates. So it basically calculates the difference between the correct and predicted coordinates for both x and y. Then it squares all of those values for the x and y, so you get the squared residuals, and then it sums them up, squares them, and divides by the number of records to get back the RMSE in the x and y directions, and then those get merged together here to create the total RMSE. And then instead of just simply return the total RMSE, I have it actually create a list object that holds a bunch of different output. So it holds the x residuals, the y residuals, the squared residuals, the RMSE in the x direction, the RMSE in the y direction, and the total RMSE. And then I also assign some names to the different objects within the list just to make it easier and more interpretable. And then I return the result. Another key thing to note here is this return. So the return function inside of the function defines what is actually returned from the function output. So for example, if I would remove this and then run the function, it wouldn't really create anything because it wasn't told what it was supposed to generate or return back to the variable. Okay, so anyway, this defines the function, and here I'm just creating some values, and then I run and test it. So let me just run that real quick. Okay, so again, here's our values. Here we ran the function, and then here we're printing back the results, just parts of the results. So this is the total RMSE, the RMSE X, and the RMSE Y. And you can see over here now I have some values. It's like vectors, and I have two functions now, and I have one data object, which is actually this list object that was produced by the RMSE function. So if I click on this drop down here, these are all the different components of the list. So the residuals, the square residuals, so on and so forth. As a quick side note, this might be a little confusing initially, but if you have an object, let me clear the console here. If you have an object, I'm just going to grab one of these, and you do something like, let's do x pred 2, and then we'll do that's equal to x predicted times 5. So what this is basically doing is it's taking each element in the vector and multiplying it by 5 and returning that into a new vector of the same length. So if you're familiar with like the concept of like broadcasting, like in Python, it's kind of the same thing. So you can multiply two vectors with different lengths. Generally what you're doing is a single value multiplied by all, taking every value in a vector and multiplying it all by the same value. So that's it. You may have wondered about that, like here. So it's basically squaring each of the residuals separately and creating a vector from it.